Hello, this is Dr. E from La Cañada High School. We are doing section 4.1 on plate tectonics. The essential skills learning objective you need to have is describe the geological changes and events that occur at convergent, divergent, and transform plate boundaries. This is basically a review from physics. There's 5 different things you need to know, basically what I just said, and then something about earthquakes. The suggested skill that you understand is being able to explain processes that are represented visually. So the Earth's structure is we have an inner core that is a dense mass of solid nickel, iron, and radioactive materials that huge amount of heat. This center is one of the hottest places, super, super hot. Surrounding it is not as hot. It's still very hot, but it's liquid. Why is this solid and this is liquid? It's because this has so much pressure on it. The mantle surrounding it, which has the highest volume of the entire planet, is made of liquid magma. It surrounds the core. It's kept liquefied by the intense radioactive material found in the core. This thynosphere is way, way up here. It's right above the mantle. It's the outer layer of the mantle, and it's right before what we call the lithosphere. The lithosphere is a thin, brittle layer of rock that floats on top of the mantle. It's broken into plates that we call the tectonic plates. Crust is on top of that. It's the very outer layer of the lithosphere. We have the oceanic crust and the continental crust. Now, there are 3 types of plate boundaries, 1, 2, and 3. The divergent plate is basically where they pull apart from each other. Basically what happens is the rising magma forms the convergent cycle, and it forces the plates apart. It forms mid-oceanic ridges, middle of the Atlantic, for example, volcanoes, seafloor spreading, and rift valleys on land. Transform, on the other hand, is where the plates slide past each other and form earthquakes. The convergent are where the plates move towards each other, leads to subduction zones, one plate being forced underneath the other. It forms mountains, island arcs, earthquakes, and volcanoes, and I'll explain more about that in a second. So the convection cycles, magma heated at the center rises because it becomes less dense, moves towards the lithosphere. As it gets up there, it cools, expands, and forces these plates apart. Then at those locations, it creates the mid-oceanic ridges, volcanoes, spreading zones, or seafloor spreading. It cools over here, and when it cools, it becomes more dense and sinks down towards the core. The spreading magma forces oceanic plates into underneath continents. This is the subduction zone right here. The sinking oceanic plate melts and when it gets back into the magma because it gets too hot. This melting forces the magma up, creating narrow coastal forces this up because it's sinking. It forces this up, forming mountains such as the Andes and also volcanoes. We'll explain more of that in a second. The convergent boundary is the oceanic. Oceanic is one of them. You can see that here. What happens is one plate goes underneath the other. It forces the magma up to the lithosphere, forming mid-ocean volcanoes, such as Hawaii, or island arcs. Also what happens is when this goes down, you see here, this is a trench. And these trenches can be extremely dense, deep. An ocean continental is where it comes in, it goes underneath, it melts when it gets back down there, it goes back up to the lithosphere, and it forms mountains, volcanoes like Mammoth, trenches. Also, when it goes under, it will have earthquakes, but when it does, it will have huge tsunamis. Another thing that can happen is we can have a continental convergent boundary, where one plate goes underneath the other, forcing mountains to come up. For example, the Himalayas, where India is going into Asia at a high speed, and that's why the Himalayas are so high. Now, with a transform fault boundary, we have one going one way, like the Pacific plate, and the North America plate going the other. They go opposite directions, and they basically fracture at a certain point. You can actually go and see it. It causes earthquake, which are the most common activity there. Because these rough edges are moving by each other, but they get stuck, and occasionally they get loose. Now, how fast is this moving? If you look at your thumbnail, how fast it grows, that's how fast these are moving. But the last time we had an earthquake, a major earthquake on San Andreas, was over 100 years ago. How long will your thumbnail be at after 100 years? That's how much they've moved by each other. As the pressure builds up, the plates keep sliding, but the edges stay stuck. When the stress overcomes the fault, the plates suddenly release, slide past each other, and release huge amounts of energy, shaking the lithosphere. We recently had a 4.0. Now, you could feel that, but that's not much. When you go to a 5.0, it's 10 times as big. Up to a 6 is 100 times as big. A 7 is 1,000 times as big. Problem is, anything over a 7, according to Dr. Lucy Jones, who's the queen of the goddess of earthquakes, is that anything above that, it can't shake anymore. But instead of being 15 seconds long, it's 4.5 minutes long. Tectonic plates can predict where there's going to be a ring of fire. Why? Because you've got basically a convergence zone where it's going down. There's offshore islands such as Japan. Transform faults, for example, along California. We've got hotspots, basically these areas right here where you've got a series of islands where basically the lithosphere is very, very thin, and therefore we have volcanoes. The new volcano is actually forming east of the island of Hawaii. Practice FRQ. Can you explain how subduction leads to volcanic activity? Hopefully this was helpful. Thank you, and have a great day.